Let's begin our study of percents with a quick review of some basic facts. First of all, percent means per hundred. So for example, 25% would mean 25 hundredths, which reduces to 1/4. So 25% as a fraction is 1/4. Quite often we want to leave our percents as decimals, so if you want to change to a decimal, just say 1 divided by 4, and you'll find out that 25% as a decimal is 0.25. 5% then would be 5 1/100ths, which reduces to 1/20th. So if you want to leave your answer as a fraction, it's 1/20th. If you want to change it to a fraction, 1 divided by 20 is 0.05. So 5% as a decimal is 0.05. The thing to notice here is that if you want to change a percent straight to a decimal and not change it to a fraction first, there's a quick way to do it. All you need to do is drop the percent sign and then move the decimal 2 places to the left. So the decimal point is understood to be here for 25, 1, 2. The decimal place goes there, and that gives you 0.25. By the same token, for 5%, you could drop the percent sign. The understood decimal point for 5 is there, and you move the decimal point 1, you have to add a 0 to go 2. A second position puts it there, and you get 0.05. So if you want to change a percent directly to a decimal, simply drop the percent sign and move the decimal point 2 places to the left. One more time, if you want to do 17%, drop the percent sign, just drop the percent sign, and then take the understood decimal point, if there's not one there, move it 2 places to the left. That puts it there. So as a decimal, 17% is 0.17. And of course, if you want to reverse that, if I give you a decimal and ask you to change it to percent, you simply move the decimal place back 2 places to the right, which puts it here, and then add a percent sign. So 0.41 as a percent is 41%. So these are just some of the basic things about percent before we get deeper. Let's look at some examples. The basic formula we'll be using for the simplest cases is what I'll call the basic percent equation. And you can see it written different ways in different contexts and different texts, but I'm going to write it as percent times base equals amount and call that the basic percent equation. So for instance, if I ask you what is 35% of 140, you would use the basic percent equation to answer that question. In this particular situation, the percent is 35%, but I want to write it as a decimal, and that would be, as we talked about earlier, 0.35. The base is what we're taking the percent of, so quite often if you look for the word of, the number following of is the base because it's the thing we're taking the percent of. So in this problem, the base is 140. It's the thing we're taking the percent of, which means that if we want to know the amount, we simply multiply the percent times the base, and 0.35 times 140. If you do it in your calculator, you'll find out it comes out to be exactly 49. Let's do another. 63 is 18% of what number? Again, we'll use the basic percent equation. 18% is the percent, but we want to write it as a decimal, so that would be 0.18. This time it says of what number. So the base is what we're looking for. So that means that 63 must be the amount. which also means we're solving for the base. So if I divide both sides by 0.18 and use the calculator, I'll find out that the answer comes out to be 350. Now don't get fooled into thinking that every answer is going to come out to be a whole number or any type of integer. It does here, just in the simplest cases, but it won't always. So the bottom line here is 63 is 18% of the base, which is 350. Let's do another. This one says 288 is what percent of 640? Well, it's easy to see here. We're going to use the basic percent equation again. We're also easy to see that we're looking for the percent, so we must know the base and the amount. The base is what we're taking the percent of, so that must be 640. That means that the 288 must be the amount. So we're solving for the percent. So if we divide both sides by 640, we get 0.45. Now that's the decimal value. To take it to a percent, you move the decimal place 2 places to the right and tack on a percent sign. So 288 is 45% of 640. And notice I've solved 3 problems, and each problem I've solved for a different variable. I've solved once for the percent, once for the base, and once for the amount. So you sort of see how that works. I've purposely kept the numbers very simple so that you can focus on the strategy and the process step by step. Now let's look at a little more involved idea called percent change. A lot of times we want to know about how much something changed as a percent of what it used to be, and that's called the percent change. But in order to find the percent of change in some quantity, you first got to figure out how much the change is. In other words, you need to know the amount of change before you can calculate the percent of change. And the simplest thing to do, I think, is just start with an example. If Jane's salary went from $40,000 last year to $50,000 this year, then I can easily see that the amount of change is just the difference between what it was and what it went to. So that would be $50,000 minus $40,000, which is $10,000. So the amount of change in Jane's salary is $10,000. That's not the percent change, that's just the amount of change, but you have to know the amount of change first. Then you want to compare it to what her salary was. That's the base. So I look at the original salary, $40,000, and I'm looking at $10,000 in relation to her original salary, $40,000. So her increase in salary as a percent, which we often call the percent increase, it's a percent change, but if it's positive, we'd say it's an increase, would be the difference in her salary, which is $10,000. It went up by $10,000, divided by what the salary was. And 10,000 divided by 40,000 comes out to 0.25, which of course is 25%. So to answer the question, Jane's salary increased by 25%. In going from 40,000 to 50,000, Jane's salary increased by 25%. I started off with an example, but I want to use that example to state the formula that I actually used, and I think it's pretty easy now to see what I did. The percent change is nothing but the change that occurred, which is the new amount that corresponds to Jane's new salary, minus what I really like to call the base, but it's the old or original amount, in other words, her original salary, over the original salary. So the base is what it was. The base is the starting value. And notice it appears in the numerator and denominator. The base is always in the denominator. The numerator is the difference between the new amount and the base. And you can see how that worked in the problem we worked. The new amount was Jane's new salary. The original amount was Jane's old salary, that's $40,000, and it appears in the numerator and denominator. 50,000 minus 40,000 is 10,000, which is 0.25, which is 25%. So that's how the formula works in general. So this is what you have to know. If you're looking for a percent change, you're going to use this formula. The percent change is the new amount minus the base, or you might call it the old or original amount, divided by the base. That's the formula for percent change. Now, I mentioned this a little bit earlier, but I want to emphasize it. This is the formula for percent change, but if the change is positive, we can call it an increase, and if the change is negative, we can call it a decrease. So this was a percent increase in Jane's salary. Had it gone down, the result would have been negative, and we would have called it a percent decrease. Al's Auto is advertising that all cars are sold at a 5% markup over dealer cost. If Al's dealer cost is $21,339 and he's selling the car for $23,295, is Al being honest? Well, here we know the dealer cost and what Al is selling it for, so we should be able to calculate the percent increase. And if it's not 5%, then he's not being honest. So sounds like a very straightforward problem. So first of all, we need the percent change formula. It's the new amount, that's what Al is selling the car for, minus the base, or the original amount, that's Al's dealer cost, divided by the dealer cost. So we simply plug those numbers in. As I said, the dealer cost is the base amount or the original amount. Plugging that in. Now the new amount is what Al is selling the car for. That's $23,295. So plug that amount in. Do the subtraction, and you get 1956. So the percent change is 1956 over 21,339. If you plug into the calculator and do that calculation, you get about 0.092, which if you change to a percent is about 9.2%. So is Al being honest? No, he's not. He's advertising a 5% markup, but in fact, in that particular transaction, it's over a 9% markup. Let's switch gears a little bit and talk about how percent relates to taxes. Here's a tax table that tells how an unmarried person is being taxed at different income levels. And the problem says June is unmarried with taxable income of $41,458. And we were supposed to use this table to find the amount of income tax she owes. So look at it closely. The column headings tell you various things. The first column tells you various beginning points for your taxable income. If your taxable income is over a certain amount, the next column is the upper limit, but not over another amount. And the third column tells you if you're in that range, what the tax is. Actually, the last two columns tell you that, but let's leave that for the moment and look at the particular numbers for June. She's making $41,458. So if you're looking at this, that falls between $30,650, that's this number right here, and $74,200. So $41,458 is in that range. So that tells us that we're looking at line 3. So the first thing to do is decide which line of the table we're reading from. Now, beyond that, you can ignore everything else. It says that her taxable income is $4,220 plus something. Plus what? Well, it's $42,200 plus 25% of the amount over $30,650. So it starts off being $42,220, but something's added to it, and what's added to it is 25% of what goes of her income that goes over $30,650. Well, it's easy to see that in order to find how much she made over $30,650, you have to subtract. So if you look at her income, $41,458, and subtract it from $30,650, it's easy to see then that she made an extra $10,808. In other words, line 3 tells you what the tax is on exactly $30,650, but she made more than that, so she's going to have to pay taxes also on that $10,808, and in fact, she's going to pay 25% tax on that extra amount. So all we have to do is take 25% of 10,808 and add it to that base amount of 4,220. So if you take your calculator and take 25%, which is 0.25, and multiply it by 10,808, you'll find out that's 2702. So if you take 2702 and add it to 4,220, what this really means is she owes a base tax of $4,220, but she's having to pay a little extra because she went over the amount that line 3 tells you what the tax is. The tax on exactly $30,650 is that, but since she made more than that, she's paying another 25% of everything that went over. If you add those two numbers together, June would owe $6,922.